We will be demonstrating how to measure phase shift with the Tektronix TDS 2002B oscilloscope. This is the BNC connector with alligator clips that we will be using. And this is the circuit we will be measuring with a 1K ohm resistor in series with a 0.1 microfarad capacitor. Now we will turn on the function generator and connect a BNC to the output like so. We will then take the alligator clips and connect them across the circuit to provide it with power like so. However, we need to set the amplitude, and to do so we hook it up to a multimeter, as shown here. Keep in mind we are currently measuring an AC voltage. We would now use the amplitude knob to adjust the unseen voltage peak to display 5 volts on the multimeter, which is now being shown on the screen. After this, we will then change the frequency to 1 kHz. Press the 1 button and the kilohertz button. Alternatively, you can press 1000 and then the hertz button. Now we change the signal wave from either a square or triangle to a sine wave. A little symbol is displayed above the number display. The function generator should now have an amplitude of 5 volts, frequency of 1 kHz, and displayed as a sine wave. Now we hook a BNC to channel 1 of the oscilloscope and alligators across the capacitor to measure its sine wave, as shown here. Now we hit auto set located on the top right to change wave proportions to a more easily read format. Be sure to use this button often, as it is very convenient as a reset. Now on the display, 2 volts per division on y-axis is shown here. 500 microseconds per division on x-axis is shown here. And the 1 kHz frequency is displayed under the finger here. At the center you can see peak to peak, cycle period, cycle RMS, and frequency again. These knobs adjust your y-axis or volts per division. It helps to display waves the way you want them to be shown. Now if you wanted to change your x-axis or seconds per division, you would use this knob. It would change your display like so. Now we will measure the wave using the cursor button here. It will bring up 2 indicator lines which we will use to measure the sine wave. We change the type of measurement to amplitude and move the cursors around using the multi-purpose knob. The measurements are taken by finding the difference between cursor 1 and cursor 2. So to find peak-to-peak value, we place a cursor on top and a cursor on the bottom. To measure voltage peak, we place the second cursor directly on the x-axis and check the delta V. Now taking a second B and C cable and connecting to channel 2, we'll be measuring the whole circuit like so. The blue wave represents channel 2, while the yellow represents channel 1. Now using the position knobs, we make the waves overlap so we can measure the shift. Make sure the errors on the side are lined up properly. Now we fiddle with the dimensions of the waves so we can more easily take readings. And this seems like our ideal display. Using the cursor and setting the type to time, we will measure the difference in theta. While currently in source 1, we move the cursor until the tiny horizontal bar overlaps the x-axis as a vantage point. In channel 2, we move the other cursor to do the same thing. Make sure the little bar overlaps the x-axis. Now we have the difference in theta between these two waves, which is 88 microseconds. Now all we need is the period of one cycle in order to figure out the phase shift. All we need to do is measure the time from beginning to end of a sine wave. Using these two values, 88 microsecond difference in theta and 1 millisecond for period, plug into this equation for the phase shift. Now if you needed help with something not covered by this video, hit the help button in the gray area and this menu should show. The index is a great place to look for a specific topic. Also, if you wish to save your data, plug a 1 GB or less flash drive into this slot here. Thank you for watching.